Okay, so switch statements. Let's get going on this thing. So we've been looking at if-else statements. We're going to look at ternary statements as well soon, like the next mini video. Switch statements don't come up that often. When they do, they're really nice, but most people don't think of switch statements. They're sort of, I don't know, the ugly duckling of this whole scenario, because at least traditionally, and I think there's new syntax for being able to do it for ranges, but traditionally was you either got it dead on the nose with a switch statement, you had to exactly have that number, or you got nothing. And so switch statements would be things like, I have a switch statement. Let me think of a good example of this. What level is my character? You can have a switch statement. So if you're level 5, you get this. If you're level 6, you get this. It could be, do you have the, has, well, let me see here. I want a good switch statement. Letter grades, not so great, but we'll look at some. Let's see if I got a good one. What section you're in, for example, what class section you're in. You're not going to be on section 2.5. You're in section 1, section 2, section 3, if there's multiple sections for your class, right? Switch statement's great for that. If I have different weapons in a video game, so I have a video game that my 2400 class is working on, zombie survival, or I don't know what I called it. But you would have different weapons in the zombie game, and they're represented as a number. And so if you got the shotgun, it's equal to 1. If you got the butter knife, it's equal to 3. If you got the chainsaw, it's equal to 17, whatever the case is. And you just have a bunch of you have a switch statement with all the various weapons in there, so you can check out what the person has. The reason you want a switch statement is because it gets really kind of clunky with an if-else statement, right? With all these curly braces and all this kind of stuff, you sort of want something in line. So you could do something like that, but it's still kind of crappy, because you shouldn't put your else if, you shouldn't put your curly braces on the same line as your else if, or your same line as your if. It's not what we're expecting. So it's very verbose otherwise. What we want is this nice compact format, but we don't want to be breaking how we normally do an if statement. So this is actually sort of the workaround. Right? I have a switch statement, and I would just put the section in it. The section is being used in all of these cases. Section is equal to 1, section is equal to 2, section is equal to 3, section is equal to 4. And then for each of those cases, for section is equal to 1, I do this. If section is equal to 2, I do this. At the end of it's also faster to execute theoretically as well. At the end of each one of these switch statements, I need this break statement, because if I do not have it, I will then merrily start walking down case 2 and then case 3. I will just keep going. I will not stop. Even if I get to it says another case, I will just keep on going. We'll see this in action, but that is a common bug for a lot of people. They forget the breaks. I constantly make this mistake. They forget the word break at the end of their switch state, each of their cases, and it just cascades to the next one. It's also something I put in the final exam last year, so in case you're wondering, yeah, it does come up. It's a lot nicer to read. The main thing is you don't want to see a whole bunch of these curly braces when you didn't actually need them, and they're get kind of clunky. Everything goes after the colon and up into the word break, and then the curly braces define the scope. So the entire switch statement starts here, ends here, right? Let's do this. Starts here, ends here. All those various cases are part of that switch statement. What is happening is I start off a section, and then I look down through each of these cases, and when I find one that matches, I do the code inside of it. So let's do an example of it, because that makes it a lot easier. Here is the number of zombies. If the number of zombies is equal to 1, I'm going to set the number of zombies equal to 4, and then break out. So it means I pop out here. If number of zombies equal to 2, I set the number of zombies equal to the pow of number of zombies. So I just square the number of zombies. So that'll be 4. And then I break out. Right? I could do a whole bunch of different things. If I don't, so the break is useful because it actually allows us to execute multiple pieces of code with variations. So let me see if I have a good example. We don't have to have a whole bunch of curly braces either. There you go. So, number of zombies is equal to 1. I set the number of zombies equal to 4. I then set the number of enemies equal to 4 squared, right? So that should be equal to 16, number of enemies. And then immediately, the number of enemies is equal to 7. What? I will keep going until I hit the word break. I will just keep on going down this thing until I see a break. I will start when I find a case that works, but once I find a case that works, I keep going down until I see the word break. I will execute the case 2. I will execute case 2 as well. So there's obvious limitations on switch statements. You need to have an actual numeric value, and you're doing the same numeric value test for, let's say, a particular variable, right? Versus an else if is a lot more variable. You can do a lot more things. It's more powerful. You can prove that anything you can do with a switch statement, you can do with an else statement. But it gets a little cumbersome in certain situations. But the else if statement also has that else, this catch all at the end. And we really want that. So the switch statement has one of those too. It's called default. I go through all my cases, and if I want to cover all other cases afterwards, I put the word default, colon, and then everything else falls into that particular case. So here would be a default, right? It's the number of zombies is equal to 1, 2, 3, or everything else. So if the number of zombies is equal to 17, it goes there. Number of zombies is equal to 8, goes there. Goes to the default. And my var at all those cases will be 22. Right? My var will be 22 unless it's either a 1, 2, or a 3. That's it. If you don't put a default, it will break out anyways. You just won't do anything, right? If I left off this default, the number of my var will or the number of zombies will only change in this case, this case, this case, and nothing will happen for all other cases. It's just good habit to get into just putting a default in there. So if I want to go from this to something else, what could I do? Well, I could say switch x, switch, and then put the variable x in there, and then I have case 1, case 2, default, and you're gonna, sorry, didn't see the cout statements, but printf statements everywhere. It would look something like this. In fact, I'd actually move this thing over as well, but fine. That's case 1, that's case 2. And my else is this default. Okay, when we come back, the final piece, which is ternary operators. This is stuff that I had to sort of get better at myself. I don't use them very often. I wasn't using them very often until I started teaching this class. So it's something that I'm now an advocate of, so it's going to be some fun. All right, talk to you soon.